You have your first common assessment on either Thursday or Friday of this week in Algebra 1. Here are the answers for your review. So when you're studying, if you want to check your answers, they're here. Let's see these things a little better. First question asks you, which one represents an absolute value function? This one right here is not absolute value, it's quadratic. This is one of the first things we did. That's not absolute value. The second one is neither is that absolute value, that is exponential. The third one, move this down a little bit, is inverse variation. And the fourth one rather, needs to be a little bigger, I guess. The fourth one is a V, and V is our clue for it being absolute variation. So I'll break this video up by page, so it'll be, I think, 4 pages. Number 2, which type of function has a constant rate of change? There's only one function has a constant rate of change, and that's something that's linear. So if you have, let's say this is your function, it's always 5 times that number, so anything that's a line would be the same rate of change. That's linear. Number 3 rather, is a function, why or why not. There's lots of things. If it's a function, the x's are different. So you can do it one of 2 ways. One way, if you take a look at the members of this, let's pick 2 points on this. Here's a point right here, which would be 3 and 4. That's one of the points. And then directly below it, vertically from that, would be 3 and -5. Because those x's repeat themselves, it's not a function. We call this a pencil test, but we were looking for x's that repeat. Let me get a different colored pen. So somebody just may draw a vertical line. If I draw a vertical line and it goes to more than one spot, meaning the x's are the same, because the x's are both 3, it's not a function. Number 4 is asking for the domain of your x's. Other words that mean domain are independent variable, abscissa. Okay, that's domain. And for range, other words for range, make it look like an R, are ordinate, range, and dependent variable. Alright, so this was asking for the domain. So the domain are your x's. I like to write each ordered pair. This first ordered pair is -3 and 1. This second ordered pair right here is -2 and 4. My third ordered pair is right here, it's 0, 0. My fourth ordered pair is 2 and 4. And my fifth ordered pair is 4 and 2. I'll put this here. Now if I want to know what the domain is, it's just everything in that first part of the ordered pairs. Right, this function notation, x such as x, in other words, all the x's are, and just list them. At least for this class, I don't really care what order they're in. As long as they're all there, that's all I really worry about. So that's the domain, -4, -3, -2, 0, and 2. And the last question for this first part of the video is, what's the domain? Domain of your x's. So your x's go from left to right. And because of this domain, we're looking for an answer that has x such that x. So the x is not all the real numbers, because this number right here, this x value of 3, is not part of this function right here. So we have to look at where the greatest or the smallest x is. Right here is the x where it all begins. It starts with a 1. And from there, they go to the left. And they go on to the left forever. So a number like the number -4 is part of the domain. It's right up here. Also the number negative, I'm going to go over here and call this -6. That's also part of the domain because this would keep on going. Even number, if I went down here for a while instead of -100, that would also be the domain because this would just keep on going. So everything that is less than or equal to a 1 will be part of the domain. Some of you guys are having trouble remembering less than and greater than. This is less than. And this is greater than. You just have to memorize them. Some people remember less than, sort of looks like an L. So the L is the less than, begins with it. On to page 2.